welcome to my podcast. Today I am standing in National Airport in front of a CFM 56 jet engine. This is one of the engines I'll be using to talk about my podcast about the engineering behind jet engines. As we know that all jet engines work on the fundamental principles of Newton's third law, for every action there is an opposite reaction. Personally, I find one of the easiest ways to remember how an engine works is by the four methods of suck, squeeze, bang and blow, and this is what I'm going to be showing on the engine. So our first principle of how jet engine works is the suck principle. We know how large quantities of air is sucked in by this propelling fan. It's split up into two parts. One part goes to the core, which where the other components of the engine works in it, and the other is follow me. The other part of the air is bypass, and it provides some of the forward force for the engine, as well as reducing the noise levels that the engine has when it's running. The second part of how a jet engine works, the second principle, is the squeeze principle. Under that, which comes the compressor of the jet engine, which is from here to here. We can't actually see inside the compressor, but if you visualize, we have a series of progressive static blades and rotating blades. These static blades and rotating blades are what take the air and they compress it bit by bit. Well, when the air is being compressed, it increases the temperature and the density of the air, and that is what is used for the combustion chamber, which we'll talk about in a bit more detail later on. We know that the compressor, it acts like a fast rotating air pump, which changes mechanical energy into pressure energy, and that's quite important for the engine to actually start running and start working. So now we're standing in the place where the compressor is actually joined to the combustion chamber, which is this part. The dense air which comes from the compressor is then forced into the combustion chamber. As we can see, this is the igniter plug. This plug is what sparks the fuel at the start, and you can see these are the fuel tubes, and they travel around the whole engine, so they're all around the engine. The dense air which comes from the combustion ignites with the fuel tubes, and this is what provides the bang within the combustion. So this results in high temperature and high energy flow, which is needed for the last part of the engine for it to actually move. So the high energy gases that have been ignited in the combustion chamber pass through and drive the turbine, as you can see here. So the high energy airflow, which is coming out of the back of the jet engine, causes the shafts that are concentric to the middle of the jet engine to suck in more air towards the front, and so thus completing the cycle of suck, squeeze, bang and blow.
Now.
And then overall, this energy flow provides a fast moving propelling jet stream out of the engine, and therefore by reaction providing an equal and opposite reaction, as we first discussed at the start of the podcast.